So I just found this Quora post, this Quora upload from the Science Space, posted by Bushen June 26, and oh hi, thought it was fun, and I just thought I should just read it out. So yeah, it goes. If a newborn baby could accelerate, I intend the one to say accelerate away from Earth at 1g, so they could also live in a normal gravitational environment for 100-year lifespan. How many Earth years would pass across their life due to time dilation? So that was the question, right? If a baby accelerates from Earth at 1g, they won't just travel far. On their 100th birthday, they will look out the window to find they have outlived the entire universe. Placed on this hypothetical spacecraft continuously accelerating at 9.8 meters per second squared, the child would experience a completely normal gravitational environment, right? To the growing child, the time would pass normally, resulting in a standard 100-year lifespan. However, the effects of special relativity mean the universe outside would age at a terrifyingly different rate. In physics, this scenario is known as relativistic constant acceleration or hyperbolic motion. For the first few months, the ship's journey would seem somewhat ordinary. But as the passenger approaches their first birthday, the spacecraft would be traveling at a significant fraction of the speed of light relative to Earth. Because nothing with the mass can reach or exceed the speed of light, the continuous energy poured into the ship's acceleration stops yielding substantial increases in velocity. Instead, the energy manifests as increasingly extreme time dilation. As the traveler's clock ticks forward, the rate at which time passes on Earth accelerates exponentially relative to the ship. The mathematical formula governing this relationship dictates that the time elapsed on Earth scales exponentially with the time experienced by the accelerating passenger. By the time the passenger celebrates their 100th birthday and reaches the end of their life, an incomprehensible amount of time would have passed back on Earth. The exact figure is roughly 1.3 times 10 to the 43rd power years. Yes, that is 13 followed by 42 zeros. To put this vast number into perspective, right, the current age of the universe is about 13.8 billion years. A billion only has 9 zeros. By the time the traveler reaches age 100, the Earth, the Sun, and the Milky Way galaxy would have been gone for an eternity. In fact, standard cosmological models would suggest that by 10 to the 43rd power years from now, the universe will have entered the dark era. All stars will have long since burned out, planets will have been destroyed or flung into the abyss, and most matter will have decayed or been swallowed by black holes. The traveler would ultimately reach the end of their life, looking out into a completely dark, freezing, and empty void, having bypassed the entire active lifespan of the universe in a single century. Okay, so that was the post, I guess.